Hey class, today is going to be 11-2, graph absolute value functions. So today we're going to be able to graph absolute value functions, but also examine some of the other ways to describe functions like the x and y intercepts, finding the zeros, the domain and range, etc., etc. So we're going to be looking also at some of those other pieces, but just know that the focus of what we're going to be doing is going to be on being able to graph it, or at least put it in the form to be able to graph it. So remember this definition. This definition is important for us to be able to graph these. The absolute value x equals negative x if x is less than 0, and then x if x is greater than or equal to 0. Now one thing to point with this, whatever's inside the absolute value is referring to this. That's all that x means, what's inside the absolute value. Anything else that's outside the absolute value, all of that remains the same. So let's look at this one. It says f of x equals the absolute value of x minus 3. So I know by definition that this is going to be, it's the negative x if x is less than 0, and it's x if x is greater than or equal to 0. And so these pieces is referring to what's inside the absolute value. So translating this is going to be what's inside the absolute value. So negative what's inside the absolute value if what's inside the absolute value is less than 0. And then what's inside the absolute value if what's inside the absolute value is greater than or equal to 0. So now solving for both of these, so that negative has to get distributed through. So to put it into a form in which I can graph it, I'm going to get negative x plus 3 if, now if I add 3 to both sides here, I'm going to get x is less than 3, and then this is just x minus 3 if, and then once again x is greater than or equal to 3. So now this is just a piecewise function, and to do piecewise functions we said, hey, let's just create these little tables for each one. So this is negative x plus 3, and then this is just x minus 3, and then I'll drop my graph here. So picking in values, I can do 3, 2, 1. If I plug in 3, I get 0. If I plug in 2, I get positive 1. If I plug in 1, I get 2. And on this one, picking values 3, 4, 5, because I know that this is where it's going to change graphs. So plug it in 3, I get 0. Plug it in 4, I get 1. Plug it in 5, I get 2. So graphing these, at 3 it's 0, at 2 it's 1, and at 1 it's 2. And then at 3 it's 0, at 4 it's 1, and then at 5 it's 2. And so I have my absolute value function there. Now, in contrast, notice this is also a parent function, right? It has a horizontal shift of 3. So if it starts there and moves over 3 spaces, that's another way for us to check it. Now, if it has that type of shift, use it. It's much simpler. We can focus it on that. So now finding all those other elements, what if I wanted to find my, x-intercept, where it crosses the x-axis? Okay, well, I plug in 0 for y. So 0 equals the absolute value of x minus 3. So then that's case 1, it's 0, so I just set the equation equal to it, add 3 to both sides. 3 equals x, so my x-intercept is going to be 3, 0. My y-intercept, that's where I plug in 0 for x. So I get y equals 0 minus 3. So I get absolute value negative 3, which is 3. So then it's going to be 0, 3. My zeros, it's also going to be positive 3. If I wanted to find my domain, if I project this along the axes here, okay, it's all going to be filled in from negative infinity to positive infinity. So if I project it here, that's going to be negative infinity to positive infinity. My range, if I wanted to project it along the y-axis, that's going to look something like this. And that's going to go on to infinity there. And so that's going to be from 0 all the way to positive infinity. Intervals of increase and decrease. So it's going to be decreasing, because if you notice it's decreasing. So from negative infinity all the way to positive 3, and then it's going to be increasing from 3 to positive infinity. And then extrema, so max and mins, I have a minimum of 0. So just describing, so all of this here is just describing the function in multiple ways. Let's look at another one. Graph this. So once again, our definition, it says negative x if x is less than, or sorry, it's just less than 0. And then it's going to be x if x is greater than or equal to 0. So I have the absolute value of x. Now remember, this just refers to the what's inside the absolute value. Everything on the outside stays the same. So this is going to be, it's going to be negative x over x if x is less than 0, and this one's going to be x over x if x is greater than or equal to 0. Now we do have an issue here. If we look at this, notice I can have a domain restriction. I'm dividing by x. X over x, if I plug in 0, I get 0 over 0. I can't have 0 in my domain. So I have to get rid of that there. So now, simplifying this, this is just going to be negative 1 if x is less than 0, and positive 1 if x is greater than 0. So now graphing this, we said it's negative 1 if it's less than 0, so here's negative 1 and here's positive 1. So open circle, and it's just a horizontal line. And then open circle, it's just a horizontal line. So now that this has been graphed, let's see, finding my x-intercepts. Well, it's not crossing the x-axis at all, so there's none. My y-intercepts, it's not crossing the y-axis at all, so none. There's no zeros either. Intervals that increase or decrease, there's nothing that goes up and down on the graph. Extrema, right? If we're thinking about max and min, we're like, oh, well, this is the max. It's the highest possible value. But if you think of the definition, we have to find a value in which satisfies this equation. And so, because it doesn't satisfy this definition here, we can't say that this is the highest possible value because there's no other value lower than that to compare it to within that interval. And let's see, what about domain? Well, my domain, the issue is going to be here and here, so that's going to be from negative infinity to 0, union from 0 to positive infinity. And then my range is going to be just the numbers negative 1 and positive 1. So now for these, because we kind of already described the information, just for these, what we're going to do is we're going to kind of sit there and just practice intervals of, just put it in the correct form. So this one's going to be f of x equals, now it's negative what's inside the absolute value, so negative x minus 3, where what's inside my absolute value is going to be less than 0, and then whatever's inside my absolute value, everything else the same stays the same, if whatever's inside my absolute value is greater than or equal to 0. And so this is what I would use to graph and find all the other information. For this one here, 4 minus 2 times the absolute value, 3x plus 1. So to set this one up, it's going to be negative here. I'll write the definition out. So negative what's inside my absolute value. Well, everything else stays the same. So negative whatever's inside my absolute value. If whatever's inside my absolute value is less than 0. And then whatever's inside my absolute value if whatever's inside my absolute value is greater than or equal to 0. So now just cleaning this up, -2 and that negative, that's going to give me a positive, so that'll be 4 times, and this becomes 2 times 3x plus 1, so that'll be 6x plus 2, so that'll be 4 plus 2, so this is going to be 6. So this will be 6x plus 6, and then this one here, distributing that through, you're going to get 4 minus 6x plus minus 2. So that's going to be negative 6x minus or plus 2. And this one here, if I subtract 1 on both sides, divide by 3, I'm going to get if x is less than negative 1/3. And then for this one, minus 1, divide by 3. This will be if x is greater than or equal to negative 1/3. And so then this is the piece that I would use to be able to go through and graph it and do all that different stuff with it. And this last one, 4 plus the absolute value of x plus 1. The same idea here. Whatever's inside my absolute value, negative of it, if whatever's inside my absolute value is less than 0. And then whatever's inside my absolute value, everything else stays the same if whatever's inside my absolute value is greater than or equal to 0. And then you'd go through and you'd simplify and you'd combine those together. But this is the end of our lesson, and if you guys have any other questions, please leave them in the comments.